Absolute Value Functions Part 1. In this video, you'll learn that when given a set of numerical guesses and a target number, how to calculate absolute errors. You'll also learn how to analyze and describe features of a scatter plot that show absolute error data. So let's look at absolute error. Absolute error is the absolute difference between a guess and the actual number. To find the absolute error, we'll take the guess and subtract the actual value and then take the absolute value of it. A scatter plot of guesses versus absolute error forms a V-shaped graph. The lowest point in the V is where the guess equals the actual number. Let's look at an example where a group of 10 friends played a number guessing game. They were asked to pick a number between 1 and 20. The person closest to the target number wins. This table shows all of the guesses of all 10 friends. So if the target number was 14, we'll find the absolute error of each friend's guess. We'll start by subtracting the guess from the target number. So we'll subtract 2 and 14, which gives us negative 12. And then we'll find the absolute value. The absolute value is just the distance away from 0. So negative 12 will be 12 units away from 0. Now let's look at 15. We'll subtract 15 and the target number of 14, which gives us positive 1. And the absolute value of 1 is still just 1. Now let's look at 10. 10 minus 14 gives us negative 4, and the absolute value of negative 4 is positive 4. Now let's look at 8. 8 minus 14 gives us negative 6, and the absolute value of negative 6 is positive 6. Now we'll look at 12. 12 minus 14 is negative 2, and the absolute value of negative 2 is positive 2. Now let's look at 19. 19 minus 14 gives us positive 5, so the absolute value will also be 5. Now let's look at 20. 20 minus 14 is 6, and since it's positive, the absolute value won't change. Now we'll look at 5. 5 minus 14 gives us 9, so we'll take the absolute value, which gives us positive 9. 7 minus 14 gives us negative 7, and the absolute value will make it positive 7. 9 minus 14 gives us negative 5, so we'll find the absolute value, which gives us positive 5. Now that we have the table, let's graph it to see what absolute error looks like. We'll start with the point 2, 12. So we'll go over 2 and then up 12. Now let's look at the next point of 15, 1. So we'll go over 15 and then up 1. Now let's look at the next point of 10, 4. So we'll go over 10 and up 4. Our next point will be at 8, 6, and then 12, 2, 19, 5, 26, 5, 9, 7, 7, and 9, 5. Now that we have all of these guesses plotted, we can see the V shape that our graph makes. We can also notice that every input has exactly one output value. So this tells us that the absolute error represents a function. Here's another one. Bags of almonds from a food producer are advertised to weigh 500 grams each. 20 bags of almonds are weighed. The scatter plot shows the absolute error between the actual weight and the advertised weight of these bags. Estimate the largest absolute error. What is the weight of that bag? So if we look at the graph, the x-axis represents the weight and the y-axis represents the absolute error. So that tells us how far away it was from the 500 that it should have weighed. Our biggest y value happens up here. This is at the point 5, 11, and then 11. So this tells us that the largest error was 11 grams when the bag weighed 511 grams. Another bag weighs 495.3 grams. What is its absolute error? So we'll take that bag and subtract it from the 500 that it should have been and find the absolute value. Subtracting these gives us negative 4.7. And then the absolute value, we'll turn it into positive 4.7 grams as the absolute error. Here's another example. A bag of walnuts from a food producer are advertised to weigh 500 grams each. In a certain batch of 20 bags, most bags have an absolute error that is less than 4 grams. Could this scatter plot represent those 20 bags? So in our problem, it says that most bags have an absolute error that is less than 4 grams. So when we look at the graph, most of the bags should be below 4 or at 4, but we have a lot of points that are above 4, so this couldn't represent this situation because we have a lot bigger errors than just 4. In this example, the class guessed how many objects were placed in a mason jar. The graph displays the class results with an actual number of 47. Suppose a mistake was made and the actual number is 45. Explain how the graph would change given the new actual number. So right now we can see that the v has a point at 47 because that was our actual number. But if the actual number was 45 instead, then it would just move our v over to 45 instead of 47. Now let's recap what we've learned. Absolute error tells us how far off a guess is from a target value. If we plot the guesses and the guessing errors on a coordinate plane, the points will form a V shape. All outputs of the function will be positive.